linear regression. So our objective for this video, find the equation of the linear regression line, also known as a trend line or a line of best fit, for a given set of data using Desmos, the graphing app Desmos. I want to point out the word linear here. The word linear has as its root the word line. So whenever you're dealing with linear, you're dealing with lines. Okay, let's first define what a scatter plot is, something you may already be aware of. A scatter plot is a graph of plotted XY points used to show the relationship, if there is one, between two sets of data. Okay, so let's take a look at a scatter plot which shows a linear relationship. I'm going to make a quick sketch of quadrant number 1, and along the x-axis we'll talk about heights in inches, and along the y-axis we'll talk about weights in pounds. So we're going to look at people, and we're going to look at their heights and their weights. And what we know just from being humans is that as people get taller, they get heavier. Okay, and that makes sense. Obviously, someone who is a newborn is only, let's say, a foot tall is not very heavy. Someone who is 10 years old and is 5 feet tall is heavier. Someone who is 6 feet tall is going to be heavier still, etc., etc. So in general, there's a relationship here. Okay, that relationship is as a person's height increases, or as people's heights increase, well, guess what? Weight increases as well in general. So taller people tend to weigh more. Shorter people tend to weigh less. So if we were to graph a bunch of people with their height, and their weight, we would find that, the trend would kind of be an upward trend, like in the direction of my pencil here. Okay, and this is an example of a linear relationship because it does kind of look like these data points fall along a line. Okay, so let's define the word linear, or define the phrase linear regression. A linear regression is an attempt to describe or to model the relationship between two different quantitative variables. Remember, quantitative means numbers. When the relationship appears to be linear, it appears from the dots you put on, from the XY points you put on a scatter plot, that they form the shape of a line, either going up from left to right or going down from left to right. A couple of specifics to statistics. The x variable, which is often for us the independent variable in statistics, is called the explanatory variable. The y variable, which we often know in mathematics as the dependent variable, in statistics is called the response variable. Okay, the equation of the linear regression line is also called the least squares line. Okay, and it allows us to make predictions for other values. The method for finding this mathematically by hand is what's called a least squares method. We're not going to worry about that. We're going to make use of a graphing app, Desmos, to come up with that as opposed to going and doing all the math. Okay, so let me move some stuff out of my way here. Okay, we're going to enter the data into the Desmos table. X1 will be the independent or the explanatory variable. Y1 will be the response variable. And then if we put the equation y sub 1, and this is the tilde symbol here, y sub 1 tilde m standing for slope times x sub 1 plus b, of course b is the y-intercept. Desmos will calculate the slope and the y-intercept for the regression line from the points we give it. How nice is that? Okay, I'm moving my stuff off my table here. So here's my example. The pressure P was measured along an oil pipeline at different distances from a reference point, with the results as shown. So X is let's first finish this. Find the least squares line, find the linear regression line, find the line of best fit, find the trend line. They all mean the same thing. For P as a function of X using Desmos. Then use the equation of this line to predict the pressure at a distance, at a distance of X equals 500 feet. So you can see our distances from a reference point are increasing. We're right on the reference point. We're 100 feet from the reference point, etc. We want to look for a point that's further away yet. That's called extrapolation. And we can see that as our distances increase, our pressure in pounds per square inch starts off at 650, but then it begins to decrease. And that makes sense. The amount of pressure as the distance gets further and further away, the amount of pressure will decrease. So this is a negative relationship. Okay, so let's take a look, and let me come up to here. I'll put this up here. I'll tell you what, I'm going to remove this from here so I can get my iPad in here for Desmos. Okay, so let's go into Desmos. I'm going to come a bit further up here. I want the data to be shown. I want to make sure that we can all see it. Almost missed it. How's that? That looks pretty good. Okay, let me turn this on. And let's get into my Desmos here. Okay, I'm in Desmos. Okay. Okay, so we need to put a table into Desmos. So let's start off by touching the X up here, which gives us the option for making a table. So there's our table. Now, using up here, our first X is 0, so I will put in the 0, whoops, and the corresponding Y, the corresponding pressure to that is 650, so for the Y, I'll put in 650. Okay, let's go on down and finish, and we'll fill in these 5 rows. At 100 feet, the pressure is 630. At 200 feet, the pressure is 605. At 300 feet, the pressure is 590. Now notice here that Desmos is already plotting these points. Now you may have to do some pinching. You may have started out, something like this on your Desmos graph, and you need to, kind of do some manipulating a little bit and to see that, to make sure you cover all the necessary Y area, the Y distance to get it, as well as the X distance. Let's finish over here. The last one says that 400 feet, the pressure is 570. So here you have it, and indeed, this data looks like it could be, it's got a linear trend to it. Those points look like they could be on a line of best fit or a linear regression line. If we were to continue, we probably would see points that would follow this general idea. Again, thinking of my pencil, whoops, so there's the line, okay? Okay, so let's find the least squares line for this. So I'm going to go to row 2 here, and I'm going to say, let's go back up to, let me get my paper. Okay, so here's Desmos telling us up here, make sure you can all see it. Here's Desmos telling us this is how you find the line of best fit. So in row 2, I'll type Y, and then I'll type the number 1. It gives me a Y sub 1. And then I need to go into the ABC menu and find that tilde key, which is down here. You can't see it on mine, but if you go down into your ABC, keyboard, it's in the bottom row. So Y sub 1 tilde. The letter M, when you put in M, Desmos reads that as slope. So there's your slope, and it's already beginning to give us some statistics here. Okay. Now I need to put in the X, and again, sub 1. Okay, again, I'm just copying this right up here for a line. And then plus B. So I need to go back to the ABC keyboard and put in a B. And there you have it. Notice what's happened. Desmos has put in a line. Okay, that's the line of best fit. That's a trend line. It is a least squares line. It is the linear regression line. All those have the same meaning. Notice that some points may be on it. Other points might be slightly off. If I zoom in here, you can see that that's not exactly on it. That's not precisely, but it's the best fit. This point is below the line. This point's above and above. But as you zoom out, of course, it looks like it's pretty good. Okay? And Desmos tells us over here that the line of best fit has a slope of negative 0.2, and we know that this line goes down from left to right, so the slope is definitely negative, and it has a y-intercept of 649. Okay, so let's take a look at that. So we'll go to here, go back to our piece of paper, and we'll note that the equation, okay, so from Desmos, okay, our y, of course, is p. P is equal to, okay, well, the slope, our slope came out to be from Desmos negative 0.2 times x, which is our explanatory variable here, and our y-intercept is positive 649. So this is the least squares line calculated mathematically for us by Desmos. Okay, so now find the least squares line. Well, this is it right here. Okay, we've got data, and this is the line of best fit, the trend line for the data we were given. Okay, now then use the equation of this line to predict the pressure of a distance of 500 feet. Okay, so over here, when x is equal to 500 feet, we can use our equation to predict that. Okay, so the pressure is equal to negative 0.2 times the distance from the point, which is 500, plus 649. We put this into a calculator, and we come up with a pressure of 549 pounds per square inch. Is that going to be what it is if we actually go there on measurement? Probably not exactly, but we know that we have some data points here. We found the line of best fit. We saw that these data points were all really close to this line, so that's going to be my guess is that'll be a very solid prediction. Okay, so there's how you use Desmos to do all the math for you. And again, the key is right here, that this is Desmos' equation for a line, y1, mx sub 1 and b, and this tilde, I think that's T-I-L-D-E, I think it's T-I-L-D-A. This tilde indicates that you're looking to match the data with a line.